Hello, this is going to be a hopefully quick video explaining where each of the conic sections comes from. The graphic I'm going to use is a GeoGebra applet available if you search the web. I did not create it myself, but it is useful for helping this out. So what we see here, this angle 30 degrees, that is the angle between the axis of the cone and the side of the cone. The axis of the cone is this dotted line that goes straight up and down. So when we have I can't change that. When we have a rotation that is at a perfect 90 degrees, we get a circle. If we were to rotate this cone, I'll just move the plane, but if we were to rotate the cones that we could look at it directly on, we would see that it's a circle. If our angle is in here in such a way that we still intersect both sides on one of the sides of the cone, if we still intersect the whole thing, we're going to get an ellipse. It'll look like an elongated circle or a flattened circle. Now this next one's going to be very hard to hit. When our rotation hits the exact same angle as the angle of the side here, so once our plane is perpendicular, not perpendicular, wrong word, once our plane is parallel to the side of the cone, we get a parabola. And in theory it would mark it red if I get it exact. There we go. And then finally, if I am between 0 and the angle given here, we will have a hyperbola. Oh, my plane can't move that way. If I'm right there through the middle, we actually get two lines that cross each other. This is one that we would call a degenerate cone. If I move the plane in such a way that I'm right along the edge, I again get a degenerate cone, just a line. And if I move the plane far enough up that I'm just cutting through that point, I once again get a degenerate cone. We are not going to deal with those in our class. We will just deal with the circle, the ellipse, the parabola that we get when we are parallel to a side of the cone, and the hyperbola. I hope that helps explain where they come from.